Welcome to the second session of the today's lecture. In today's lecture, I am discussing about a deadlock. In my first video, I have discussed what is deadlock, how deadlock occurs in the case of a multiprocessor and the multi-computer. Now, basically, there are four reasons or there are four necessary conditions for a deadlock to occur. And these necessary conditions are your mutual exclusion, non-preemption, resource waiting, and a circular wait. So let's understand what do you mean by a mutual exclusion. Here each process has an exclusive resource of its resources. It means that there should be a resource that can only be held by one process at a time. So there will be a one single instance of each resources, and it is held by the single processor at a time. Now let's come to what do you mean by a non-preemption. Here a resource cannot be preempted from a process by force. If a resource is already held by some other processors, it cannot be taken forcefully. A process can only release a resource either when it completes its task or if the processor wish to release it. Now talk about the resource waiting. Here a process can hold multiple resources and still request more resources from the other processors which are holding them. And last is your circular wait. In circular wait, each process in the cycle waits for a resource that the next process owns and will not relinquish. Here a process is waiting for the resources held by the second process, which is waiting for the process held by the third process, and so on. So these are the four necessary conditions for a deadlock to occur. Now, how we can deal with the deadlock? Now, there are three ways through which we can deal with the deadlock. Either first, detect the deadlock in the system and find a solution for it. The second is your deadlock prevention. If we try to prevent one of the four necessary conditions not to occur, then we can prevent a deadlock in the system, and through deadlock avoidance we can also try to deal with the deadlock. Using wait for graph, Banker's algorithm, we can deal with the deadlock avoidance. In the deadlock prevention, it is very important to prevent a deadlock before it can occur. Here, the system checks each transaction before it is get executed to make sure it does not lead to a deadlock. So this is all about the deadlock. Thank you.